Now, just like living organisms are made up of lots of tiny cells, everything in existence, whether it is living, non-living, or even a single cell itself, is built from countless tiny particles that we call atoms. In fact, these atoms are so incredibly small that even a single microscopic cell is estimated to contain more than 100 trillion atoms working together to form its structure and enable its functions. In today's video, we are going to dive into the world of atoms and try to understand exactly what they are and what they are made of. The first and most important thing to understand is that each atom is not an indivisible object but is in fact made up of even smaller particles, and its general structure consists of a dense central core called the nucleus, which is surrounded by a set of electrons that move around the nucleus in regions we call shells or energy levels. Now, while we usually show these electrons orbiting in neat, circular paths in diagrams, the reality is much more dynamic, with electrons constantly moving around the nucleus in a cloud-like formation. The nucleus itself contains two specific types of subatomic particles called protons and neutrons, which are packed very tightly together in a compact spherical mass, and it is crucial to remember the structure we just described because it helps us understand the fundamental differences between these particles. Both protons and neutrons have the same relative mass, which is defined as 1, while electrons, on the other hand, are vastly smaller, with a relative mass that is approximately 2,000 times less than that of protons or neutrons, which is why we often say the electron's mass is negligible or effectively zero when compared to the others. Now, when it comes to electric charge, protons carry a positive charge, which is denoted as +1, and an easy way to remember this is that both proton and positive start with the letter P. Neutrons, as their name suggests, are neutral, which means they carry no electrical charge at all, and electrons carry a negative charge of -1, which is equal in magnitude but opposite in sign to the proton's charge. To keep things simple, we remember it as positive protons, neutral neutrons, and since only one type is left, the electrons must be the negative ones. In addition to charge, remember that both protons and neutrons have a relative mass of 1, while electrons are significantly smaller and lighter. The size of an atom varies depending on which element it is made of, and we will discuss elements more in the next video, but generally speaking, atoms have a radius of around 0.1 nanometers, which is unimaginably small, and despite their size, most of an atom is actually just empty space because we measure the size from the dense nucleus at the center all the way out to the outermost electron shell. And much like a solar system where a star sits in the middle with planets orbiting far around it, atoms have a similar structure, with most of the space between the nucleus and the electrons being completely empty. And while our diagrams often exaggerate the size of the nucleus for visibility, in reality the nucleus is about 10,000 times smaller than the atom as a whole, and electrons are even smaller than that. In fact, if we drew electrons to their real scale, they would be too tiny to see. Now, in the atom we have illustrated, if there are 3 protons in the nucleus and 3 electrons orbiting at the positive and negative charges perfectly cancel out, making the overall atom neutral, but atoms can lose or gain electrons, and when they do, this balance is disrupted, resulting in a charged particle, which we then call an ion. For instance, if we add an extra electron to our atom, we now have 3 protons and 4 electrons, meaning the negative charge is stronger than the positive one, so the atom becomes a negative ion. In this case, we say it has a 1- charge because it has 1 extra electron. If we added yet another electron, it would become a 2- ion, since it now has 2 more electrons than protons. Similarly, if an atom loses an electron, then there are more protons than electrons, so it becomes a positive ion. For example, if we have 3 protons but only 2 electrons, the ion has a 1+ charge because the positive force is greater than the negative. This leads us to the periodic table, which we will explore in more detail in another video, but for now the key thing to know is that each box in the periodic table represents a different kind of atom, which we call an element. So, for example, one box represents oxygen while another represents lithium. These boxes show what we call nuclear symbols, and they convey a lot of information. The first thing you will notice is the elemental symbol, which is the 1 or 2 letter abbreviation for the element, like O for oxygen and Li for lithium. Then in the bottom left corner of each box is the atomic number, which tells us how many protons each atom of that element contains. For example, all oxygen atoms have 8 protons and all lithium atoms have 3. This atomic number is extremely important because it is the number of protons that defines what element the atom is, regardless of any other particles it may have. Finally, in the top left corner of the nuclear symbol, we see the mass number, which tells us the total number of protons and neutrons in the atom. If we want to find out how many neutrons an atom has, we subtract the atomic number from the mass number. So for oxygen, with a mass number of 16 and an atomic number of 8, we subtract 8 from 16, giving us 8 neutrons. Lithium, on the other hand, has a mass number of 7 and an atomic number of 3, so 7 minus 3 gives us 4 neutrons, meaning lithium has 4 neutrons and 3 protons. And just like we said earlier, the number of electrons in an atom is equal to the number of protons, so lithium also has 3 electrons. And oxygen has 8, so that wraps up everything for this video. We hope you found it helpful and informative, and if you enjoyed it, be sure to check out some of our other videos. We will see you next time.